The next one we want to look at now is the RS flip-flop. Okay, so for the RS flip-flop, you agree with me that you have your set bit 0 0 1 1, reset bit 1 0 1 0 1, and then you will have your output to be for set bit, for reset set bit, reset set flip-flop, your set dominates, right? So when the two of them are not pressed, 0 0, you have 0 here. When the set bit is not pressed but your reset is pressed, you have 0 here. When your set bit is pressed but your reset is not pressed, you have 1. Now, but when the two of them are pressed, because set dominates, you have what? You have 1 here. That's the idea. Already, they don't need to tell you before you know that this particular instruction will not what? Will not work. But at the same time, I can still repurpose this particular what? Program. So I still have my normally close of the stop button, the I0 dot I0 dot 1, I0 dot 0. Abi? So this I0 dot 0, am I correct? So then my start I0 dot 1, the start, and then your output. Okay, let's say Q2 dot 0. All right. So and then the latching that we have here, Q2 dot what? Dot 0. Are we together? So now this is for SR. Now, how do we now infuse RS here? What's the condition for RS? The condition for RS is such that when the two buttons I0 dot 0, that is the stop, and the I0 dot 1, the start, when they are pressed, okay, we still want the set to what? To dominate. So let me represent this one as M0 dot what? M0 dot 0. So at that point, I can bring M0 dot 0 here. Which bypass this initial condition. Okay, so what will be the case? Now let's test it on this our truth table. When the two of them are not pressed, there is a signal state of what? Of 0 here, 0 here. So there's an inversion. This is 1, and this is what? This still remains 0. 1 and 0 will not agree. Okay, 1 and 0 will not agree. So for that reason, this will be what? But as you are doing that, you need to confirm on this end as well. Okay, so at this point, you know that what your RLO at this point will be what? Will be 0. Okay, so let's see what this bypass will do for us. Of course, when the two of them are not pressed, there is 0 here, there is 0 here, there is 0 here, there is 0 here. So this guy is not coming on. So even at this point, you still have what? 0. So your output is still what? 0. So we are cool. The next one, we want to consider the set bit and the what? And the reset bit, where the set bit is not pressed, but the reset bit is what? Pressed. So which is the set bit? The set bit is the start. Okay, it is not pressed. So you still have 0. Okay, and then the stop bit is pressed. You have what? 1. So this gets inverted. So you have what? 0. But this is still 0 0. So you still have 0 at this particular what? At this particular point. For this case as well, for the stop, you have 1 here, you have 1 here. 1 and 0 does not agree, so there is still what? 0. It means at this point you still have what? 0. So this is still what? 0. Okay? So the next one now is to look at a condition where your what? Where your set bit is what? Is pressed. Okay? So the set bit is pressed, but your stop bit is not what? Is not pressed. So the stop bit is not pressed, but your stop bit is, but your start bit is pressed. So at this point, 0 inverts 1. Okay, this still remains 1. So there is a signal of 1. Whatsoever happens from this point, this guy is still going to what? Come on. So that makes that work. So but now we are left with the last one when the two of them are what? Pressed. So when the stop button is pressed, when the start button is pressed, when the stop button is pressed, when the start button is what? Pressed. So at this point, this gets inverted. There is a 0 here. This remains 1. 0 and 1 does not agree. So at this particular point, you have what? A 0. But at this point, let's come here. When this is pressed, 1, you have a 1 here. This is also pressed. You have a 1 here. So these two agree. For that reason, there will be a 1 here. So you have a 1 here. This has bypassed the whole system. So at this point, you have what? 1, which is why your Q2.0 will come on. That's why your so this forms an RS flip-flop. Okay, so let's look at somebody else's program to confirm. You have a normally open. Okay. Normally open, no? Normally close. Okay. Then to the coil. So let's address them. The set, which is the start button. So that's I0.1. Abi? Yes. So, and then here, encore, we have the lamp here. So, which is the output, Q2.0, Q2.0. Okay? Here, encore, the reset, which is the stop, I0.0. Okay? So, let's take this through our test as well, if it's going to pass it. Okay? The first one is when the two of them are not what? When the two of them are not pressed. When the start button is not pressed, there will be a 0 here, and there will be a 0 here. The two of them are not pressed. So because of that, this one gets inverted. You have 1, but this one is still 0. There is no signal at this point. Normally, this is supposed to supply a signal of 1 to this point, but this condition have not been met yet. This guy has not come on. The only time this condition will be met is when this is on. So that for that reason, you still have 0 at this point. So this confirms that this particular line. This confirms this particular line. Okay, the next one is we want to consider a situation where the set bit is not pressed, but the start is what? But the reset, which is the stop, is what? Is pressed. Okay, so this is not pressed. So of course you still have 0 at this point. This is pressed. This will invert what? 0. So 0, 0 will still give you a 0 at the end. So this also confirms this other line. Okay, then let's go to the third one. When your set bit, which is our start, is pressed. Okay, and then when our stop is not, it's not pressed. So when the start is pressed, signal of 1 will be here. So whatever it is that these guys are doing, it's none of our business. This guy will flow. But don't forget that how set work is such that once it is on, once the signal pass, it should remain on even if the button is not pressed. So let's see, will that happen? So because this stop button will be in the state of what? 0, and it will invert what? 1. You don't forget that 1 has gotten to this point. So automatically there will be a 1 here and 1 here. 1, 1, 1. So it will hold on to it. For that reason, this will remain on. So this also passed the third test. So the last one is such that when the two of them are what? Are pressed. So when the two of them are pressed, okay, when the two of them are pressed, okay, 1, 1, 1, 0. So 1, 1, 1, 1 is such that signal of 1 flows directly to this guy. Okay, so even though this one inverts this to 0, it's not it's none of anybody's. So for that reason, this also passed the test of the RS flip-flop. So that is it.